Just over 3 months after a young resident of Bundung came up with a prototype helicopter in a year of science, technology and innovation, another young Gambian is at it again. Amadou Gueye of Nemakungu has discovered how to produce biofuel and other byproducts from a local plant. Modou Lamine Cissé visited the boy's home and he reports the discovery is not only amazing but also a potential source of renewable energy.
Has the declaration of 2012 as the year of science, technology and innovation been what talented young Gambians have been waiting for to practicalize their scientific talents? However, even if that is not the case, we can certainly say that it has set them thinking, thus trying to unlock the doors of success in the sciences. Their results have most times been remarkably good, sometimes even amazing by Gambian standards. On tonight's edition of Weekend Spectrum, we bring you an extensive feature of how Amadou Gueye, the young Gambian whose 2 years research into renewable energy recently came to fruition, did his work. He discovered a biogas that is environmentally friendly and that also has good economic prospects. Resident at Nemakungu, the former Muslim senior secondary school Kamar student has an undeniable intuition and aptitude for the sciences. During a recent exhibition of his discovery, Mr. Gueye took time to explain to his audience the chemistry involved in his research in the theoretical form.
Sodium chloride, the electrolysis of sodium chloride and water will give you sodium hydroxide and hydrogen chloride. You can see here, the same sodium hydroxide is used to react to hydrogen sulfide, result from the decomposition of the grains. And you can see here the reaction of sodium hydroxide to hydrogen sulfide will resolve water and sodium sulfide. Here also the same sodium hydroxide will be used to remove the hydrogen, the carbon dioxide. That's here. Here is the reaction. Here is the recycling. You see, so hydrogen chloride. The grains is the major component of the biogas production. The salt is just used to produce sodium hydroxide. We use just small quantity of sodium hydroxide, and also the water can be recycled again.
This local plant, said to be widespread in the Gambia, is the main raw material in the experiments leading to Amadou's discovery. The plant, the main product it produces is methane gas. The byproducts, namely ammonia and cake, are used as fertilizer and as industrial source of heat. Ibu Job, a UTG student, is Amadou's leading support colleague in the 2 years research. Out of his own initiative, he used his mathematical skills to design a tool typical of what Amadou Gueye needs to carry out his practicals. He explains how he went about the process.
This is a plate. We join it by a cone and attach to a part of a circle. Then the part of a circle forms this portion. We also have a frustrum of a cone, or a frustrum of a pyramid. This is a truncated cone, or a frustrum of a cone. When the cone is constructed, it is folded to form a solid figure. Now, this is a condenser. A condenser is formed by joining a rectangle and a part of a circle. When the part of a circle is constructed, it is attached with a small cylinder by folding some diameter. Then this is also a cone. Then the cone is joined with the cylinder to form this condenser. Now, we also have 2 tanks. All these tanks are formed by using cylinder. The cylinder is joined by using a rectangle and a part of a circle. It is also joined by using a rectangle and a part of a circle.
With the literature that guide the process and the tools used already available, as one would expect, Amadou went straight into the production process of the gas, attracting a group of onlookers wherever he goes. Amadou first mixes the boiled seeds of the plant with sodium hydroxide. The mixture is then put into the machine with the help of electricity. After the machine is filled with the raw material, it is taken to the main workshop where the process that induces the gas is done. With the use of a battery, Amadou continues the process.
See, now it starts. Here is the condenser. You can see. This is a water pump. It makes this water to get into the reactor, to get into the condenser. It's put inside. Circulate. This one makes. This one will take air into the reactor, so that this cool can burn inside. Here we don't have to use molecules. It's just to promote the chemical reaction. Here is the blower. The blower. Here we have this thing is the control panel. It is what I use to control the machine. You can see the blower is on. Now air is getting inside. After the system starts for about 1 minute, then gas starts to produce.
That is exactly what happened. After a while, the gas was produced and we saw it coming.
After the gas is cooled down, then it becomes colorless gas. Now you can.
The gas is then filled into a balloon, a substitute for our gas bottles at home. By Ibrahim Job, sponsor of Amadou's research, sheds more light on the nature and importance of the gas produced.
As you can see, it's very powerful and also it's very clean. It's a very clean gas. Yeah. So this is just volume. So
over time, the balloon will go down because the gas coming out of it is
gradually used. Yeah. So like this is, you know, like if you look at a 10 kg bottle of gas, if you have a pressure, now we can press this into a cooking gas, and then that's, you know, just what we use for our cooking. Yeah.
All that young Amadou now needs is the required financial, moral and technical support to improve on his invention. He will want to make it commercially viable, and that is only possible when there is support. The irony of a commerce student being able to make such excellent scientific discoveries only underscores the need for more career counseling in our education system. People's talents must mark their areas of specialization if optimum success is to be attained. Modulamin Sise, GRTS News.